Well, thank you for coming. It's a great pleasure to see high attendance and earlier arrivals. Does it mean that everyone is interested to start earlier, or just because of publications on Friday?
Well,
Okay.
we gotta go.
Huh?
Yeah, and
We have chemistry club at like 6, so we're gonna leave a little bit early.
Okay. What do you do in chemistry?
Good fun.
We do demonstrations.
We do.
Nitrogen ice cream or something more?
Kind of, not quite that.
Did rockets last year.
Sugar rockets?
We do like a 2-liter bottle, and then we put like ethanol or something. Ethanol or I don't remember. Ethanol, I think. And we dumped it out, and then we just like put a little flame by it, shot it up,
Huh.
stuff like that.
I probably need to finish earlier.
Yeah, you keep coming out.
There's pizza.
Good pizza, from free pizza.
I should have led with that.
Yeah, pizza, it's free
Free
dinner.
pizza. Everyone's welcome.
I probably can register for undergraduate just. So we will do two things. One, I will go over whatever is missed in the list, and then I will illustrate one of the problems for the homework number 3. So if you don't care what I'm doing here in front of you, just focus on your topic for Friday presentation and just practice it on computer, make screenshots and stuff them into PowerPoint. I want to announce and declare that there is one champion in the class who has already prepared the slides for the Friday. So, someone was really quick. I don't know if I should announce so that people do not get jealous of the champion. Oh, everyone starts looking around. Good. So, just before we go on, the presentations are not academic in the sense that, like, finding portion of material in Wikipedia and presenting. The idea that you present your own story of success and failures, your own experience in trying to do one of these things, and warn audience of not repeating your failures and repeat your success. Okay. So, did you get the MATLAB code in the email? Were you able to run it? Okay. So this is very much today possibly work. It wasn't working last time. Maybe today it is better. So what we are doing in class, we are trying to find such wave functions that will be zeros at edges and will be non-zero in between, right? And there are some standard procedures to solve such equations, but this is the simplest possible equation. It is much easier probably to solve it analytically than with a computer, but just in case, to show power of computation as well, you can solve it numerically. The idea, I'm partially repeating what was on the lecture, the idea to solve this equation with boundary conditions is that we already set up class of functions
and then assume that they enter into solution in a superposition, as a summation of several functions with unknown weight coefficients. And our question is just to find the right weight coefficients in such a way that they will match the boundary condition. So when we were in class, during the last 15 seconds, I was quickly giving something on the superposition of exponentials, right? I do have the slides, but I do not want to distract your attention with more questions than is needed. And then through Euler equation, we can go back from exponentials to sines and cosines. So last 15 seconds of the lecture were that instead of two traveling waves, one can so if I'm telling something boring, just focus on your presentation, right? Make screenshots and save into PowerPoint. So one can look for solution in form of trigonometric functions. And in this expression, we do not know expansion coefficients A and B, and we do not know the quasi-moment of the wave vector, right? So by finding these three constants, we will find the solution for particle in the box. And in lecture materials, there was a little connection between these coefficients in front of exponential towards coefficients in front of trigonometric functions. So before we go to numerical solution, there is a little intellectual exercise. So this boundary condition problems is not like a typical mathematical problems when you see it, derive, and do standard operations like integrate 5 times, differentiate 3 times, and get the answer, or whatever, right? So it is less formal operations, more informal thinking. And we do want to explore this function at the limits when the independent variable is equal to either 0 or L. So if our independent variable is equal to 0, 0 is a cosine. So no matter what is the multiplier, just cosine 0 plus b sine 0. What is the value of cosine of 0? 1. So 1. So this equals a plus, and what is the sine of 0?
0.
Times 0. So we do want, so right now we need to think a little bit. So it's at which conditions, so A and B are known coefficients, at which conditions this can be equal to 0? Can we say something definite about values of A coefficient? Yes, why? I have difficulty explaining it, even to myself, not just to the class.
If it's B, it'll be 0. If it's anything other than 0, it's not.
Do you follow it? Everyone agrees? So just from this logic, A must be equal to 0, which means our expression immediately becomes much simpler. We just get rid of this cosine. So from now on, we will be looking for solution in the form of phi of x equals unknown coefficient b times sine kx. Nice? More thinking, less calculating. There is one requirement that I'm always forgetting to declare, but you did declare it in the presentations on postulates. If we already know the solution, and we want to integrate it, what should be the total probability that we have one electron? So the product of wave functions is a probability distribution, right? And the at given density of probability at given interval of positions. But if we integrate area everywhere under the curve, it gives us number of electrons, right? So what's the number of electrons in this problem? Huh? How many? It's a very trivial answer. Do not hesitate. Yes, we never talked about 2 electrons yet. Plus 1. So this gives an additional condition to find the coefficient B, right? But the coefficient K is a little challenge. It is not challenge mathematically. You probably know the answer right away. It's one line. But what is the logic behind it? So quantum problems, especially this most trivial standard quantum problem of solving time-independent Schrödinger equation, these problems do have many solutions for one equation. So we should expect that more than one value of this K variable will give the right answer. Okay? So we have several constraints. We know that our function should be just sine multiplied by a constant. And we want to match this function with a condition. We already used this one, the limit at left side, and we didn't use this one. So we want our function to be 0 at the right edge. Okay? So I'm keeping the intrigue, although I'm confident that any of you can get the answer in 10 seconds from now. I will spend about 20 minutes. So what we are doing in this little code Okay, I'll take a break for maybe 1 minute. And, please practice and develop your own idea of what is going on with this code. Okay. So we do not know the values of k, but we do know, and right now we are forgetting about the coefficient b. So we are going to scan all possible values of k, plot the wave function, and see if it will, by its right tail, whether it will touch the x-axis. Okay? So we set up, we prepare that value of this k parameter. For simplicity, we are setting up that length of the box will be 1, otherwise it will take a little bit additional complication. And then we scan values of the k from 1 to 12, splitting it on grid points. Well, there is no challenge to your computers if you do like 1,000 grid points, but we need to be quick and practical. And then we are going through the wave function which will look differently for each value of k, right? So it's same axis but different number of fringes. And then we will compare if the value of the function at the point when x equals L, in independent parameter equals L, is smaller than some criterion, some tolerance. So we cannot, when we do numerical solutions, it is very hard to get the literal equivalence, something really equal to each other, 0 or whatever. Therefore, we are just setting up some predominant error tolerance limit, and then we are checking if our wave function at the rightmost edge is smaller than this tolerance. And if it is, we will record which values of k will give the right answer. So here we have position, and we are describing particle in the box. So here is the box, right? The red lines are tolerance. So we will plot different candidates for correct wave function. We already know that it matches the criterion to be equal to 0 when x equals 0. But then it will or will not match the tolerance criterion at the right edge. So it's like shooting from rifle. You can hit the target or you can miss the target, right? So the wave, as you know, wave functions has yellow color. I'm joking. I will just use yellow color for our trial functions, candidates, and they will become dark black if they hit the target. So after you run the code, you may want to hit enter several times. So this line, first, and this one, is a sine function with very, very long period. And it does match the target. Later on, you will show that it is not a good solution because the integral under this curve will never get to 1. So it is trivial but wrong solution. And if you go further, so it is another sine function with very long period. So right now you see lines that go higher and higher up, right? And if you are running this code on your computer, just keep hitting enter. So it is, you'll see a little hump. So this is a sine function that will end somewhere in the next classroom, right? So it just makes quarter of a period. Now we keep going further, further. So it still misses the target. You know, it's like throwing the rock from ancient Rome ballista, catapult, right? It goes, and the target is here. It's coming there. But if we continue increasing k, we can predict that it will fall into this range sooner or later. Not yet. Yes, it hits. Then it hits again, and it hits again, right? So right now, we do have this tolerance limit that we have artificially increased. Therefore, with this criterion of precision, there are several values of k. But if we will shrink the tolerance limit, finally there will be only one in this range. And our main question was the shape of the wave function. So it is a sine function for the half period, right? After the half period, it hits there. Then we keep going, and you see these yellow lines again miss the target, and nowadays yellow lines go below the dark one. Further, further, further. So it is very far from hitting the target. But now you see it develops, it makes almost the full cycle, and now our new line approaches the target from below, right? So if we keep going further, further, almost hitting. Oba. So now this sine line hits the target. Therefore it becomes black because it is a good solution. Okay? So we go further. It is more than one solution in this interval just because of the tolerance limit. And if we hit enter further, we go again, again, and again. No hitting, no hitting. You see, now it looks more like sine function goes up and down and then again up, right? And then we go further, further, further. You see, it develops the motion down in this area. And if you go further, it hits the target range once again. And once again. And then it stopped. So we already got about 4 solutions. The trivial one, and then 3 harmonics, right? So you see that it is sine function, but not any wave vector, not any values of k will provide the solution. So we already agreed that the function needs to be sine function, but we made together by watching and silently agreeing on this, that there are magic numbers for wave vector that will make sine function a solution of Schrödinger equation for particle in the box. I'm going to make a circle around the classroom and make sure that you all are feeling happy. First, you need to define that. Yes,
You already have
we already have two champions who submitted the presentation. Yes, and you don't care who is outside. Yeah.
No.
Talk to each other. Those who installed, share experience with others. I know if one needs to go to a special website, type in your student ID, something like this. It's if you try to do it as a stranger, it will cost like 500. But if you are with student ID, what is this? Is it part of yours?
Yeah.
This email is a part of your presentation.
Save, load, and run. So I'm saving it from the email. Well, I'm running it from the email, and then I'm saving it again.
Okay. I will go over things because there is something
Is that a little bit wrong?
in addition. Yes.
Oh, but I thought I had it easy.
Well, no, you're correct.
Yeah.
But there are more things. Okay, and if you keep doing it further, where is this? Upon completing this cycle, it will show the plot of values of k on the x-axis. There will be another plot with criterion on y and also norm on y. So if we keep going, at one point there will be a pop-up of one more window. So this is with vector k. This is our tolerance limit, and this is value of absolute value of sine at point x equals L at for different values of k. So this region corresponds to straight lines parallel to x-axis. Okay. Then it goes far away, and then it provides another hit inside the tolerance limit. It is when we have one hump of the wave function ends, half period of a sine ends at the right edge. Then it doesn't match tolerance limit again, and then when it matches, it is one full period of sine, going up and down and then coming to zero, right? And you see there are more than 1 points here because of the tolerance limit. Ideally, we need to lower down tolerance limit closer to zero, and then we will have only one solution. And if you do not have enough grid space, we can have zero solution. So it's little things of numerical. And then we have 1.5 period here. So another thing is normalization. It is implemented just by summation of a function and multiply by dx. Some of you is presenting numerical integration, right? So basically it is, right? I don't remember who, we'll check it out later. So we are looking on the red line, red line that corresponds to norm. We need to see that this norm is non-zero at a time when original criterion is met. So the first solution, when the wave function is parallel to x-axis and close to zero, norm is also close to zero. So we need to cancel this solution. It will be not physical because it will give answer as 0 electrons. And we know that we need to have 1. Okay, and those will be okay solutions for the values of k. Now, if you hate math so badly that you do not want to deal with any solutions, you may check what will be the value of k for this minimum of the criterion. So this one is somewhere between 2 and 4, but it is closer to 4. So it is something like 3.1, right? This one is a little more than 6, about 6.2. 6.2, and this one is a little above 9, so it will be maybe 9.4. Does it remind you any of famous numbers? Do not hesitate. I see it in your eyes. Anyone else recognizes this number? Okay. Ben?
Pi.
Right? So pi, 2 pi. This will be like 3 pi. Right? So it is values of k at which sine function will pass through right edge. Okay? So this is answer for homework 3, problem 5, and we can get the. Oh, any questions about this stuff? Convincing enough? I'll make another circle so you can ask questions in private. And, So at this point, we can demand that phi of x equals L must be 0. So sine of x times k, k times x, will be 0. And here we just ask ourselves at which values of k sine is equal to 0. Not L. Not L. And L right now, so we know that the sine will be equal to 0 if the argument, if k times L equals 0, pi, 2 pi, 3 pi, and pi times any natural number, right? But we do not need L, we need only k. So we divide left and right part by L. So k equals 0 divided by L. And by the way, we cancel the solution because of normalization criterion. Pi divided by L, 2 pi divided by L, 3 pi divided by L, and then we write down n times pi divided by L. So the allowed values of wave number are proportional to, they're discrete, so there is infinite number of solutions, but they are discrete. The k vector is proportional to natural, inversely proportional to size of the box, and it has this pi function. So the wave function number 1 will be unknown coefficient up front, sine pi divided by L multiplied by x. Phi 2 will be coefficient sine 2 pi divided by L multiplied by x. Phi 3 sine 3 pi divided by L multiplied by x. Probably I've told too much. Now I do not know how to grade this problem, but let's assume that I was not telling this. So I'll make one more circle around the class, and then we'll go to protocols for practical skills for MATLAB.
So just like.
Yeah.
It's not with that eye.
I guess my neighbor will like it.
I think I'll July times 0.
Yeah.
Is there
Good. Good. Yeah.
More questions? This one is most challenging problem in the whole homework, except the extra credit. The rest is easier. It's either looking through the notes or whatever. So I have no doubt that everyone will succeed. Yeah. I don't know, when I play with this remote, it stops showing good things on the screen. Maybe it's a sign that I shouldn't play with remote. What is that? I don't know how did we. Oh, okay. No, it shows back the computer of what we did in class. Okay. So here is the list. The animations will take most of the time, so probably I'll leave it to the end, and it will be like 20-25 minutes to go over. Who is Joseph? Okay, so you were brave enough to choose eigenvalue problem in MATLAB. Huh. Did you ever diagonalize the matrix before? Did you ever diagonalize a matrix? Probably
I
not.
believe I would remember how to do it off the top of my head.
Okay, then the good news that you get new experience. Okay, well, please attract my attention if you have problems in presenting either of these things, but I will right now focus on eigenvalue, although it is a little boring, but we need to get through it. Okay? Okay, so if we do not care about the meaning of the diagonalization, here is the command to explain to those who are not here or who is not focusing on the screen right now. So you define the matrix, and it doesn't need to be 2 by 2. It can be something bigger. And then you perform operations EIG for eigenvalues or for diagonalization, and you forward the answer into two new matrices, U and V. And one of this answer matrices will contain eigenvalues, and another will contain eigenvectors. Okay, that's it, done. But I do not think it is helpful enough. We need to go into more details, right? So I'm going to erase stuff from the board and give a little of the ground. Well, generally, if it would be a mathematician who would talk about it, they would try to be general, and even for 2 by 2 matrix, try to write like A11, A12, A21, A22, and then diagonalize. But we can go simpler right from this example with realistic numbers. Or we can do both, actually. So, by now, it is assumed, I would be really happy to assume that everyone knows what is determinant and how to find it, right? So, the diagonalization of matrix would be such matrix that acting on a vector, it will reproduce vector itself. So basically it's Schrodinger equation, right? If you want full agreement, we can even call it like H11, H12, H21, H22. And this will be Hamiltonian, this will be wave function, and this will be unknown energy. So by acting of this matrix onto this vector, we obtain the same vector again, times some factor. And the procedure of finding this unknown energies and functions is done by finding determinant and making it equal to 0. So if we subtract left and right part, we will get H1 minus E times minus E, H12, H21, H22 minus E, multiplied by x1, x2 equals 0. Is it clear, or one needs to explain what it is? So this constant there is nothing wrong to put identity matrix anywhere without any permissions. Like if you multiply this vector by this identity matrix, nothing happens, right? By row by column, you'll get the same vector. But now, if you subtract left and right, it means that you will subtract matrix H minus matrix, this identity matrix, and then multiply it by this vector. Okay? And if you open up this subtraction of a matrix, it means we subtract first element and first element, second element and second element, third and third, fourth and fourth, right? So H11 minus E, H22 minus E, E12, H21. equals 0. So I don't care about theorems, but they do exist. And one of the theorems that is that if you take determinant of such subtracted matrix and make sure that it equals 0, you will come to a polynomial equation that will help to find you unknown energies. It will help you to find eigenenergies. And later on, if you plug in eigenenergies into this equation, you will reproduce eigenvectors. I'm tired of myself. I don't know how about you guys. Maybe enough for pure theory. Let's practice with this 1, 2, 3 matrix. Otherwise, it will be too boring. So 1, 2, 3, 4 minus e minus e. Determinant equals 0, which means we need to product of diagonal minus product of diagonal, right? So 1 minus e times 4 minus e minus 3 times 2 equals 0. Minus 4e plus e squared minus e minus 6 equals 0. So e squared minus 5e minus 2 equals 0. Please correct me if I'm wrong, because I like to make, well, I do not like, but it's human nature to, the simpler the problem, the higher chance of mistake. Now, how do you find solutions of the second polynomial? Yes. Equals minus b plus minus b squared minus 4ac divided by 2a, right? Okay, let's plug it in. So b is minus 5, minus b is 5, a is 1, 2a is 2, plus minus square root, b square will be 25 times 4 times 1 times minus 2. Right? Which will be 8, 25 plus 8, 33. Good. 5 plus minus square root of 33 divided by 2. So square root of 33, it will be a little less than 6, maybe 5.8. We can double check it with calculator or computer later on. So approximately it will be 5 plus minus 5.8 divided by 2, which will be two solutions. One is 10.8 divided by 2, and another will be minus 0.8 divided by 2. So which will be about 5.4 and minus 0.4. Look at here. So if you didn't quote me lying on this little exercise, I blocked it with screen not intentionally. So if this answer plus 5.4 and minus 0.4 is not wrong, then it looks like we have a great success. The diagonalization procedure, finding eigenvalue and diagonalization means the same. It is synonymal words, which you may introduce for those who is not aware, or for the record. So the V matrix contains two blocks, or just diagonal. So it is diagonal matrix with eigenvalues placed on the diagonal. Okay, so it is what MATLAB does. And do you really want for eigenvectors? Do you really want eigenvectors? Me to tell about them, or you want to sit and figure it out yourself? It can be a little bit longer and more boring, but I can probably just sketch the logic. So as soon as from this determinant you got polynomial equation, you solve it and you get answers, E1 and E2, right? What we've got there on the example. Now you return to your original equation. And you plug in subsequently one eigenvalue and then second eigenvalue. So after you plug in the eigenvalue, the E capital stops being in the unknown variable, right? So it will be H11 minus E1, H12, H21, H22 minus E1. So first time it is E1. And now it acts on the unknown vector and it gives 0. So right now, the only unknown things are these components of a vector, x1 and x2. So this is linear algebraic equation to find x1 and x2. Right? And if you solve this linear algebraic equation with E1, you will obtain the vector C1. I just do not want to solve it. It is possible, but it will take time and exhaust the whole class. And then when you plug in the E2, you will get the second vector. So the first matrix that comes out of this exercise is composed on the eigenvectors placed together in a matrix form. Okay? Good. Whew.
We gotta take that off.
Huh. So many of you are going to Chem Club?
Looks pretty awesome.
How often does it go?
Once a month.
It's once a month, yeah. Next month it won't be during this time. 'Cause
Yeah.
It's kind of a weird thing,
Good.
so.
I should plan making it quicker in 1 month and maybe joining you. Especially if you
Pizza.
burn or combust something.
Oh, yeah.
Yes? Uh-huh. I'll just approach you. Okay? Who is Joy? Not here, left for Chem Club. Then I skip it. Gauge. Okay. Basic graphics for functions. Derivative and finite differences in MATLAB. Integration by sum. Do you need any help and comments on this? Okay. So as we did before, you just define x-axis with some grid points, and then practice this sum for integration of something, and diff for differentiation. And you should try some example. I don't know, sine polynomial, and show what result is. Better in graphical form, because otherwise numbers are boring. Okay? Try something and talk to me while we are here. Isaiah? Okay. Vectors. Is it clear, or should I show something?
The dyadic product.
Okay.
I looked it up and I wasn't sure.
We already did it here once. Let me cover it partially. So if you set up, I don't know, vector x equals 1, 2, which will be vector column, and then you set up vector y equals 3, 4, which will be row vector, right?
Yeah.
You can multiply them following rule row by column, so y is row multiplying by x, which is column, and then you get a number. Then?
I write it.
Oh, okay. But
I figured it out.
perfect. Right? One number. But what if you swap order and write, instead of y times x, write x times y? Yes. So it is dyadic product. So you make a product of the same objects, but in different order. So the order that matches row by column is scalar product.
Okay.
And the one that expands dimensionality is dyadic product.
Okay.
Make sense?
Yeah.
Okay, good. Caseman is not here, so I shouldn't present anything on transpose, determinant, and row by column, right? We did it a couple of meetings before, and since she left, probably she knows what to present.
How long are we presenting for?
We split the 50 minutes on number of class attendees. So do not go over 3-4 minutes. 3 is better. Give others
You
chance.
want like this kind of brief from the basics?
Examples. If let me tell what I do not want.
Okay.
So two bad limits that I want to avoid. First limit, just read something from Wikipedia and copy paste without trying.
Okay.
No, bad limit. Another limit, open MATLAB on the podium and try typing something and trying. It could be correct, but it will take like hours. So you just take screenshots and give quick guide.
Okay.
The stuff that we are doing is really simple and quick if you just show screenshots, right? We're not doing too complicated things. Joseph, eigenvalue problem in method. You have enough in it. It will keep you busy. And I admire you, how brave you are. It's most complicated in all of them. It's well, I do not have access to grading in other classes, but by presenting this stuff, you're worth of A in linear algebra. Whatever, how many credit course it is. Ben has already left, but I want to briefly mention. So suppose, so I'm going to make comment on this red stuff. So suppose we have a matrix, and I'm doing exp of matrix, and I'm doing expm of the same matrix. Just observe this little numerical experiment. So you can apply regular functions not only to numbers, but also to vectors and also to matrices. But exponential is most important function. Look at here. So our matrix A starts with 1, and you see this is E number, like e to the power 1. This is likely e to the power 2. So if you write exp of A, it will take each element of the matrix and place it as a power of exponential, and then form a new matrix. But if you put exponential matrix exponential, result will be very different. You see how different it is, right? So what this function is? A little spot right here. So who doesn't know about Taylor series?
I remember doing them in Cup 2.
Okay, anyone not remembering it? You don't remember?
I'm shaking on it.
Okay, so if you have exponential function in the vicinity of 0, right, it will be approximately equal to 1, right, with some slope. So x, 1 plus x. And then it starts curving up. So plus x squared over 2 factorial, right? And you can continue the thing. If you apply the same Taylor expansion to matrix, if you take identity matrix plus exponential plus matrix in the first power plus matrix itself plus matrix multiplied by itself divided by 2 squared, 2 factorial plus so forth, so this will be exp m of A. So it is instead of plugging in elements of matrix into exponential function, it is taking matrix as a whole object and forming Taylor expansion. Right now we don't care, but at the last month of the class we will have project where everyone will do the same. Okay. Dylan? Not here. Anyone has problems with plots? Two-dimensional, three-dimensional plots? No. Okay. Morgan is also not here, but you know how to change background, right? You just double click on a figure, and then there is a pop-up menu to change thickness of lights, fonts. Okay. Now I make a little break to prepare well, and then I will do the animation for Bill.
Yes, sir.
So for number 2, the general solution for the time dependent is just the summation of the initial condition minus your eigenentry times your expansion coefficient.
Yes, correct.
So then is your input to the time dependent just your operators? Or would it be some form of kinetic energy?
So, to time dependent, the input is the functions, energies, and expansion coefficients.
Okay, and then your output would be your
Wave function is.
wave function. Oh, okay. I see what you're saying.
No, it's not tricky. It's
Oh, okay. It's just straight out.
done.
Copies emailed to you then?
Huh? Yes.
Go ahead and say it's a physical copy, really.
What do you mean physical copy?
I got it.
want it through your Gmail or your DSU?
CC to all of my emails.
Okay.
Thank you. Okay, I have sent an email and everyone can enjoy it, but it is intentionally targeted for Bill. So please open your email and see if you can follow the YouTube link. You will see Blue training and check if, and then try to run the code. So the communicating your scientific achievements to other people is critically important thing. When there is a limited time, you cannot run your codes, hit enter again and again. You need something work on a snap. So there is a way to record sequence of images into movie file and then insert it. Import it into the PowerPoint and play it while presenting. Closer to the end of the course, if you've been exercised for a grade. I think it is not too much. So there are special commands to generate such movies, and what I did try and what I did send is to add the special commands into the little script that we did practice today in class. So you see, it does work, and now it is on YouTube, right? Cool. Interesting. Let me double check if I didn't hit enter. Okay, so reply to all. I'm doing it publicly. Changing subject because it's something moving. Pasting the link to YouTube and adding an updated and sending. Well, I did CC to myself and it did went through. You're getting it?
No.
No?
Oh, there's one.
Okay.
I got it.
So try to play and to run the script. Yes, okay. So now I'm inviting Bill for special attention. So in MATLAB there is a help bar when you type names of the commands that you want to learn about. It types how to use them, right? So try to seek help for write video command. Write video. as one word. And then it will appear the following article. So skip. I'll show which part of this article is really needed.
See you on Friday.
Yeah, see. So if you scroll about 50% through this article, you'll see the right comments, just in case you can focus on that. So you need to copy the following commands into your code. So suppose that you have a code that scrolls through a set of images, right? So before you start cycle on images, you need to reproduce this one. Set GCA next plot replace children, meaning that it will be not accumulating on the top, but each object will come up as a new one. Now you need to open. You need to. It's really important thing. You will enjoy it, and we are close to completion. So, if you do need to create video, if you are programming in MATLAB and you need to create video, so copy this command at the beginning of your file, and then open channel for writing video. So video writer, assign some variable. Here it is letter V, but you can do anything else. So video writer, then name of your file, and then open the channel. Now, if you do have a cycle where you repeatedly develop some new image again and again, you may want to add two lines. One, frame equals get frame, and second, write video, frame to the V, which means to this video file, you add new snapshot, new frame, okay? And at the end, you write close the channel. So if you perform this operation and run the code, at the end, when the code is completed, so you can do here the ls, which is the list of your files in the directory. So I named this file for movie test.avi, and upon running of the code, it does appear there. So if you do run this script yourself, it should pop up here. So we are not programmers here, but later on we will need to do this operation for many other codes to just put in this special lines for making videos. So if you open this code and scroll through, you see at the beginning we put this set GCA video writer and open V. So, okay. Then we go to the part where we do plot our trial wave functions, and approximately at the same place where we did pause for stopping, you add delay. So it's not, if you add delay, it doesn't stop anymore when you hit enter. It just waits a little and gets further. And after this point, you are copy pasting these two special commands for frame equals get frame and write video into your frame into the channel. Okay? And when you get after cycle is closed, you write close V. Now you can if I want to run it again, I can rename it and run it again. So you see this develops as we did before, and as we go through, it does record these trial functions into the video file. And when it is done, the video file is available for so in the PowerPoint there should be a button for inserting video, right? So if you click on this you insert this video into PowerPoint, and next time you present it, you can run it. Okay?
Also, I can directly just put the video
Into PowerPoint, yes, yes, yes.
Okay.
So you have twofold goal. First, make sure it works, and second, teach everyone to do the same on Friday.
Is that the only animation that we're doing? Because there's other stuff too, like doing transforms and making.
You can try adding this animation into any code you're writing.
Okay.
So right now, we don't care what you animate. It's just a practical skill of making your figures to animate.
Okay.
And since it is more than 2 lines, there is a chance to make error. So you can just explain reason for these lines and instruct others to run them. I'll make circle and check if you feel happy.
Oh, okay, okay, okay. I see what you're saying.
So you are with. Hmm? So, who? What should come up if you type?
I don't think anything will come up unless you define who. Will it?
Me.
Oh.
No, it will give you a list of variables that you recently practiced.
So I know that, but okay.
I'm expecting you to present it to us. So
Oh.
let's take a seat. Now it's I think you have variable like xx. So you do have size. Okay, they are the same size. Now you can develop new variable I do it without mistake. So it makes two columns of data.
Oh.
No. Save. Oops. OS for the list of files. See, there appears file named answer. Let's see. So the data that we processed in Meta zero zero 009 they're the same. So I'm saving data, I mean this one.
Okay.
So that later on you can open it with your other favorite program, which I don't know, maybe Excel.
Okay.
So,
Okay, you can open it with Excel, so actually.
yes, let's check.
We're on open.
Import.
Browse. And then go to where I don't know where it is.
And now you can
Open one column.
you know better how to plot things in Excel.
I do know how to plot things, but they're in one column. These things are in one column.
Okay, then it's
But there's an option, I'm sure, is going how to fix it. Do you want me to show how to put it into Excel or just show how to write it into
yes,
Excel?
yes, because some of your class, well, I hate Excel, but some of your classmates are really like it.
Okay.
And you need to show that MATLAB is not standalone. You can
Okay.
transfer data, or if you are experimental learning modern instruments, save data in form of Excel. So you MATLAB saves instrument can create data that you read in general level for suppose so now if I do clear, it means I delete all variables, no variables. But now I decide, oh, okay, I need to call this data back. So okay, so now I take this. It gives, it reads it back. Just load. And if I want to check that it's the same data I do put, it's it's on the outputs. If you need X and Y. So, column means all elements. One means from the first column. That's X, Y, Z.
Okay.
So load and save data.
Okay, I see what you're saying instead of what I.
Yeah, you're fine to keep your other stuff as well if you can match it in your system. This is very practical because some future assignments will rely on this.
Alright, I'll do my best.
Thanks much.
Everyone satisfied? The rest of you is sufficient, right?
Your call will be disconnected.